Assalamualaikum and hi everyone. Today I will excited to share with you guys our presentation on subject signal and system about our end of chapter topic 1 and topic 4. And this is our teammate. My name is Nushaira F1102 Muhammad Shukri 08 DEU4B and my teammate is Nabakis Atirah Rente Abdullah 08 DEU23F1110. So this is our introduction. Signal processing is the foundation of many fields in electrical and electronic engineering. It involves analyze, modify, and synthetic signal, whether continuous time and discrete time. Next, these signals are essential in practical application, like communication, control system, and audio processing. This project helps us explore basic operations such as addition, multiplication, and shifting, and also how to transform signal using FFT. So for question 1, we were asked to show the basic operations. That is addition, multiplication, and shifting between two continuous time signal and two discrete time signal using software MATLAB. Okay, so for this part, we were given two continuous time signal. That is x1 equal to sin 3 pi t and x2 equal to cos 6 pi t. Our task was to perform basic addition operation between two signals. When we add them together, the result is xt equal to sin 3 pi t plus cos 6 pi t. So this operation helps us understand how different waveforms interact when we combine. So by adding this signal, we get new waveform that carry characteristic of both sine and cosine function, which is useful in signal and synthesis and analysis. Next, we perform the multiplication of the same two continuous time signal. When we multiply them, the result is xt equal to sin 3 pi t at multiple cos 6 pi t. The multiplication creates a modulated signal, which is commonly used in communication system. It combines the frequency component of both signal and giving a more complex waveform. This technique is useful in amplitude modulation and signal mixing. So that is the last task for question 1. That is for this operation, we apply a time shift to signal x1. That is sin 3 pi t. By shifting the signal to the right by 1 second, we get the new equation. Is xt equal to sin 3 pi t minus 1. So this means the signal starts 1 second later than before. Time shifting is an important concept in signal processing because it helps us control the time of signal, especially when synchronized system or analyze delay in communication.
Question 2. Synthesize the conversion of three selected time domain signal to frequency domain signal by using fast Fourier transform function. This is referred to Flag 5. For the FFT sine wave, let's begin with the first signal, a pure sine wave at 50 Hz. In the code, we define this using the sine 2 pi 50 t function and calculate its FFT. The plot shows a single peak at 50 Hz, which is expected since a sine wave has a one frequency component. This confirms the accuracy of the Fourier transform in isolating the frequency content. Next, we have the square wave. Though it looks simple in the time domain, its frequency spectrum is more complex. The FFT reveals multiple harmonic frequency, the fundamental at 50 Hz and its odd harmonics at 150 Hz, 250 Hz, and so on. This is due to the square wave being made of a series of harmonic sine wave. In the final signal, we combine two sine waves, one at 50 Hz and another at 130 Hz. As shown in the FFT plot, we see two prominent peaks corresponding to these frequencies. This demonstrates how the FFT can compose a signal into individual frequency components. For the conclusion, we learn fundamental signal processing concept in the assessment by practicing basic operation addition, multiplication, and shifting on continuous time and discrete time signal using signal processing tools like MATLAB, Skylab, or Octave Online. Our hands-on practicing reinforce what we know about the characteristic of signal in various time domains. We also developed the conversion of time domain signal into frequency domain form using the fast Fourier transform FFT, a seminal instrument of modern signals analysis. It is crucial to master them for the further learning and application in communication control system and digital signal processing. This is our reference that we use for this presentation. Okay, that's all from us. Thank you.